Going on now to topic 4 of chapter 5, multiplying polynomials. Well, multiplying is sort of easy, and we have a couple of techniques we want to go over here with you. And here we see we are multiplying a monomial by a monomial. So we would multiply the coefficients and get 8. And then we add the exponents. In this case, this is going to be x to the second. Multiply the coefficients. A negative 6 times 5 is a negative 30. And we add our exponents. Now when we do 4.1 times 6, they're both positive, so we get 24.6. And now we have to add our exponents. So there's a 1 and a 1, so x to the second. Y to the second and 5 is 7. And keep in mind there's a 1 on the z, so 10 plus 1 is 11. So these were multiplying monomials. Now back to chapter 1 when we did the distributive property. We're going to multiply the 2 by each of these terms, being careful of the signs. So 2 times 3 is 6. X to the first gives us x to the second. 2 times a negative 4 is a negative 8. And then we just have the x. So some more. A monomial by a binomial, doing them carefully. Let's just do E and F and give you a chance and see what you get. So check these out and see if you got them right. You want to check your signs. You want to check that you've collected and added all your exponents correctly. And generally, we put them in A, B, Z form, as opposed to Z, A, B, or something. We try to alphabetize, but MATLAB should accept it if you did it another way. Okay, we're going to go on now to letter G. And for these, there is a special technique that I'll go over. This is one of the ways to do it, where you take your x term and then multiply it by this, 2x squared minus x plus 5. And then you take your second term, which is a plus 3, and multiply it by this, 2x squared minus x plus 5. This is one way to do it. We'll give you a moment to do it. So I do the x times 2x squared and get 2x to the third. X times a negative x gives me a negative x squared. X times 5 is 5x. Then I do these. 6x squared minus 3x plus 15. And now what I have to do is combine like terms. Well, I only have this, so I get 2x to the third. Now this and this are like terms. So I have a negative 1x squared and a positive 6x squared. This will give me a positive 5x squared. Now I have these. A positive 5x and a negative 3x leaves me with a positive 2x. And then I have just the 15 left. So this is doing it horizontally. A little later we're going to show you that you could also do it vertically. Put the x here, plus 3. And then this is gone. And then you're going to multiply each of these by this in like term columns. But I'll illustrate that a little later. Now, going up some more, we're showing here binomials that we could do in a similar way. We'll take the x and multiply it by this, 3x minus 4, and then the 3x minus 4. So here we get 3x squared minus 4x, and this will be plus 9x minus 12. And then we look for like terms, and the two terms in the middle are like terms. So we get 3x squared plus 5x minus 12. So this is one way to do it. Now another way they're suggesting is we use the method that's called the FOIL, where we do the first terms, which are the first in each of the binomials. Then we do the outers, which is this one and this one. Then we multiply the inners, which is this one and this one. And then we do the last, which is the last of each of the binomials. So notice that each of them now have two lines underneath them indicating I've multiplied everything. So let's do it. X times x is x squared. Now when I do my outers, I get x times 3 is plus 3x. When I do my inners, I get a plus 2x. And now when I do my outers, I get a plus 6. Remember, you're multiplying. Now we have like terms in the middle still, sort of at this stage. And we get x squared plus 5x plus 6. Now, the use of the FOIL is pretty much an important method for doing these that you need to practice. Because in later sections, we're going to take this trinomial and factor it back into its binomial factors. And sometimes we use this technique too, as you'll see. So this is an important method to practice. Now, over here we're saying we could also, when we have a binomial times a binomial, do it vertically. So we go negative 2 times negative 3 is a positive 6. Negative 2 times 4y is a negative 8y. Now we go to the next item. 2y times negative 6 is a negative 6y. And we put it in its like term column. And then 2y times 4y is 8y squared. Now we draw our line and just add them all up. 8y squared minus 14y plus 6. So, in a sense, there are three ways to do a binomial by a binomial. But this is the way we want to feature, because it's so useful when you're trying to factor this into its binomial factors. Now there's other things going on, and we want to feature those methods as well. So as we move it up, we see we have two terms, or two sets of parentheses that are the same. Both terms are the same in both. So another way to write this would have been, oh, I got that big thing again here. Parenthesis x plus 6, the quantity squared. Now, there's another way to do this, but let's FOIL it for this time. Our outers are x squared. I'm sorry, our first are x squared. Our outers are plus 6x. Our inners are plus 6x. Notice these are the same, which will be useful in this other method. And then we multiply our last. 6 times 6 is sort of like 6 squared is 36. So this gives you then x squared. These two are identical, so we can just take 6x plus 6x is 12x. It's sort of like doubling the 6x. We get 12x plus 36. Now, while we're here, and I have illustrated it this way, let's do it this way also. This is called squaring a binomial. Now, one way is just to write it twice like this and FOIL it. But, again, you want to get the right answer. This is a special method that will be useful in your next course. That we square this first term, which is what we did here, x times x. We squared that first term. Now we multiply these two terms together, get 6x. Now double it. That would be 12x. When we did our outers and we did our inners, we got the same terms. And that's like multiplying these two together and doubling it. And then we square the 6, which is 36. Now, these, when we square a binomial, have a special name. This is called a perfect square. And write this down. Square trinomial. So when you square a binomial, you get a perfect square trinomial. And you might say, well, what's the significance of that? Well, if you recognize that something is a perfect square trinomial, it will factor into a binomial square, in a sense, into this. Okay, now let's FOIL this one and see what we get here. First will be 3x to the fourth. Outers is a negative 18 x squared y squared. We do our inners. We get a negative 4x squared y squared. And when we do our last, we get a positive 24 y to the fourth. Now notice we still have like terms in the middle that we need to combine. So we get 3x to the fourth minus 22 x squared y squared plus 24 y squared. Okay. Now this next one's a little more challenging, and I'm going to clear this so that we have a little more room. So when I do my first, I get 12 y squared. When I do my outers, remember I'm multiplying, and I'm going to just do it crudely. I'm going to get a negative 3 over 6, just multiplying 3 times 1/6, and then this will be y. So 3y times a negative 1/6. It's just putting a 6 underneath there and then being sure it's negative. Now my inners, I'm going to get a negative 4 over 4y. And I'm going to simplify this in a moment. Then I do my last, and I get a positive 1 over 24. Now, a negative 1/2, or 3/6 is a negative 1/2, and this is a negative 1 here. So this is going to be a negative 1/2 and a negative 1. Put that in parentheses, y. Now, when we want to join these together, this would be a negative 2 over 2 is what 1 is. So this becomes a negative 3/2 y in the center plus 1/24, and over here is 12y squared. And let's see if that's the answer they give down below here. Let's look at it here. Yes, that's the answer. And this one, again, was a little tedious because of the fractions, but hopefully you see how we worked all that out. All right, let's go on. Now, these next two are in the area called special products. Now, why are they special? Well, we're going to basically do a modified FOIL on them, but they're done a special way. And we mentioned this before. This is squaring a binomial. So we'll do this one together. We square the first term, multiply these two together, get 2x, double it, get 4x, and then square this term. So this is a perfect square trinomial. Now how about this one? Square it. Multiply these two together. You're going to get a negative 4x, double it, negative 8x, and then square the 4, and you get 16. A perfect square trinomial. Now I noticed, in checking the final just recently, some students had put a plus here. Well, it's what is there, and then you just double that, keeping that same sign. So if it's positive there, it'll be positive there. Negative there, it's going to be negative there. All right, let's square this one. X squared. Multiply these two together. positive 7x, double it, positive 14x, and then square 7 plus 49. Now this is called squaring a binomial. Now for this, we're using the formula a plus b. This is the rule, a minus b. Now you'll notice the terms are the same in both parentheses, except one is plus and one is minus. Now when we FOIL this, we get a squared from the first. The outers are a negative ab. The inners a positive ab. And then we go negative b times positive b gives you a negative b squared. But something interesting happens when we square these. And by the way, this arrangement has a special name, and I'd like you to write that down. They're called conjugates. And whenever we FOIL conjugates, look what's going to happen to the middle terms. We have a negative AB and a positive AB. They're just going to cancel out. So we end up then with what is called the difference of perfect squares. The negative indicates difference. This is a perfect square, this is a perfect square. So when we multiply conjugates, and it would be the same terms, just different signs, we just have to do the first and last. So x times x is x squared. A positive 5x times a negative 5x gives me a negative 25. So this is the difference of perfect squares that would factor into its conjugates. So 2 times 2 is 4 x squared y squared minus 9 b squared. I try this one. This is 25 x squared minus 1/4. Remember, your products will always be perfect squares and the difference of them from multiplying conjugates. Now, this one's a little different, so I'm going to clear this up and show it to you in some detail. So here, if you remember, let me write it out for you. 6 minus, in parentheses, 2b minus 2, parentheses, the quantity squared. So we're going to square this, and that'll give me 36. We're going to multiply these two together, and it's a negative, so it'd be a negative 6 times this that we have to double. So it becomes a negative 12 times this. And then we square this, which will be 2b minus 2, the quantity squared. But we haven't finished yet because we have to get rid of these parentheses. So this is 36 minus 24b. Now a negative 12 times a negative 2 is plus 24b. No b there, sorry about that. And then now we have to square this. So square this first term. This will be 4b squared. Multiply this is a negative 2 times 2, negative 4. Double it, negative 8b. And then square this. My wife came down and kind of distracted me a little bit here, but, you know, after all, it's her house too. All right, so now we want to combine these like terms here. So we have a 36, a 24, and a 4 that adds up to 64. We have a negative 24b and a negative 8b that add up to a negative 32b. And then now we're just left with a positive 4b squared. I would have lined it up the other way, but I see the book is lining it up this way, and this one was sort of a challenge because it had lots of stuff to do and used a lot of technique that we've been working on. Okay, let's move it up a little bit now. And we go into our mixed review down here a little bit. We're multiplying stuff like this. So, you might say, well, what do I do here? Well, the first thing we have to do here is FOIL two of these. So let's do that, and I will get back to you. Now, as we do this, I FOIL this and got this, and then I multiplied it by this, which I'm indicating here, and I'm going to do it vertically to illustrate that for you. So negative 1 times negative 6 is a positive 6, and then this becomes a negative x, and this becomes a negative 1x squared. Now, you can write the 1 or not. Either way, you could put a 1 there too if you wanted here. Now we go 2x times a negative 6 gives me a negative 12x. This times this is a positive 2x squared, and this times this gives me a 2x to the third. I kind of wrote that 3 pretty big there. Now, I have them in the like term columns, so now I just vertically add them up. Here we could put a 1 there, but don't, because MATLAB doesn't like that. But there was a 1 there when we did this, and added these up, and this is the answer. Checks out. Now, this one is interesting, and it's challenging too. Now, think we could do it this way. Y minus 2, the quantity squared, times y minus 2, the quantity squared. Okay, now, that's a little easier instead of writing it out 4 times, because now we can use that special technique where we go y squared, square this first term, multiply these two, double it. That's going to be 4x plus 4. And this was going to be the same. So it'll be y squared minus 4x plus 4. Now we're going to multiply that, and we get, a series of terms that we will get item by item. I guess I should do that, but I'm going to set it up a little differently here. Okay, we got this initially, dividing it into 2 parts, where we use that special way of squaring that, squared this, and now we multiply 4 times this, 4 times this, 4 times this, got this row, 4 times this, started to get it, and I changed colors so it would be in red, and then this last row, and I put them in like term vertical columns. Then added it up, and there's your answer. And again, this took me a while to do, and if you had one like this, it would take you a while to do it as well. Okay, let's take a look at this one now. Now notice these are conjugates. So I can multiply these and get x squared minus y squared. These are the conjugates, and they get the difference of perfect squares. And now I have to multiply it by this one, x plus y. And again, I'm multiplying now. So this times this gives me a negative y cubed there. This times this gives me a x squared y. And this times this gives me a negative here, and they're not alike terms here, a negative x y squared. And this times this gives me x to the third. So I don't have any like terms, but this is what I get then. X to the third minus xy squared plus y squared, x squared y minus y to the third. And I believe that is correct. And I checked this, and this should have been a negative up here. So that is a negative. All right. Again, these take time, and I would check the work carefully. Okay, we're going on to our last row now, where we're dealing with function, and it's asking us to do some substitution. And I'll get back to my nice red color here. I like the red. And I like the thicker point too. So what do we do here? Well, we had said that when we have something like this is our function, and they're giving us, instead of an x here, we put an a there. What do we do here? Well, we have to put the a where the x is. So this is going to become a now to the second, because we're substituting the a for the x minus 2a. And that's all. Now here they're asking us to substitute a c for the x. So this will become c to the second minus, substituting the c for the x, 2c. Now here it gets a little more challenging because they're asking us to substitute an a plus b for the x. So as we start that, we're going to go a plus b, that is for the x that we have to square, and this will be minus 2, and we substitute the a plus b for the x. So this is something we can handle. We're going to square the a. Multiply these two together, we get ab. Double it. 2ab. Square the b, and we get b squared. Minus 2 times a is a 2a minus 2b.